Welcome to the presentation about integrated digital factories. My name is Jochen Tanger. I'm Senior Solutions Engineer in Central Europe, located in Munich. This presentation focuses on the AEC advantages of an integrated factory, the design of the building itself, the collaboration and the convergence of BIM and the production layout and processes. A similar presentation of this one is also available with a focus on the factory design utilities and the mechanical and production industry. Let's have a look at the agenda first. So we look at given a short overview, we look at the goals, we look at the software that can be used in a digital factory. We look at the factory design utilities as well for the layout planning. We look at existing conditions and also reality capture. So how do we really get the building out of it? Then the building interoperability and collaboration. Data exchange informed design as different ways of collaborating and exchanging files or data. Then we look at the simulation processes, the infrastructure, the visualization, and last but not least, the operation, because the operational phase is more and more important. And then we will have a short conclusion. Let's start with the overview. Production and construction is subject to constant change. These changes are driven by the introduction of new products, the change in demand in terms of quantity and types, a serious point in times of COVID, for example, also cost reductions, while maintaining the same quality. And last but not least, the change of supply chains worldwide. Around the central integrated factory model, there are continuous processes that need to be planned and coordinated. You can see that there are many different stakeholders involved, from manufacturing, the production processes, layouting, the architects and engineers, finance and purchasing departments, supply chain teams, and of course, subcontractors. Most companies work in functional silos. Little attention is paid to the company-wide flow of information. It's hard to find, the information is hard to find, inconsistent, often outdated, and difficult to interpret. This leads to errors, delays, and inefficiencies. And most companies do not even realize how many layers of redundancy they have built into their businesses as usual processes. In fact, Forrester research reported that we are using on average 45 different apps or services every single day. But that data is siloed, and people spend about 12 hours a week just for digging or searching for data. And we can do better, a lot better. So let's have a look at the goals we have. Our goal for an intelligent 3D and BIM process of the integrated factory is to coordinate the wide variety of different disciplines and supply everyone with the latest data. Here we can see the production planning, media supply, ventilation, lighting, water, electricity, for example, and of course the building itself, designed in different solutions, different departments, or even companies. But the reality in many companies is that layouts are still created in 2D. These layouts are usually readable only by professionals with a lot of experience and are error-prone because the third dimension is not included. All accompanying documents are distributed, such as Word, Excel, PDF, or handwritten documents are distributed by mail. And of course, we do see a data exchange here as well, with different layers, linked files, and many copies with different standards of the 2D floor plan of the building, the desired production area, the layout of the production itself, and finally the MEP design. This certainly results in a complete layout. However, the level of information and readability is limited. So the goal is to elevate these traditional processes to the next level and beyond. As a first step, a building floor plan is certainly a good first orientation. The product areas as well as the media supply area can be represented as a 3D construction space. In this example, this is created in Revit and linked in Inventor. The layout planners then fill the assigned areas with machines and the production layout. The model is completed with a media supply and the building from Revit. This integrated 3D building and production data workflow enhances all processes for the digital factory, allows a much more intelligent coordination and communication, resulting in less issues, less time invest, and cost. Let's have a look at the software that is included or that is possible and can be used in a digital factory, in an integrated digital factory. And as you can see, it is a lot. There's a lot of different solutions that we can use. So the planning and coordinating of a digital factory with many different workflows, disciplines, building life cycles, teams and companies, it can't just be done in one solution. However, our goal is to use the best Autodesk solutions to solve all requirements and intelligently combine different Autodesk solutions with the least amount of data loss and the latest data exchange, collaboration and communication tools. Many products are bundled in the AEC and PDMM collections, so it's easy and affordable for our customers to use the same methods and workflows. So now let's have a look at the factory design utilities, just as a short overview, because in this case we want to concentrate on the AEC part of the digital factory, but at least I want to show what the factory design utilities are. So with the factory design utilities, it is possible to create the layout in 2D or in 3D. And this is unique in the market. 2D users can work in the familiar environment and then switch directly and associatively to the 3D environment. Alternatively, a layout can create it immediately in the 3D environment. The central libraries are available in AutoCAD and Inventor. The goal of the FDU is to simplify the data, to create new assets, to chain assets and also connectors, and the layer management. There are plugins available in AutoCAD and in Inventor. So now let's have a look at the existing conditions and reality capture. In this case, we do have a 2D plan, a 2D drawing, like a DWG drawing, as a first step. We can use the lines and layers of that 2D plan to create intelligent grids and also walls and facades and so on, so that we can create the first floor plans, for example. But we don't have any information about the height and any other information. But in this case, we just had a laser scan. So as you can see here, it's just we don't really have the height, but with a laser scan, and even though the laser scan is not quite have a good quality, it's just one single laser scan, but at least we can see the height, we can see the roof, we can see the facades and so on. And that's what we can use to really create the whole 3D model in here. And then we can fill it with more and more information, maybe use some other laser scans, maybe we have some other data that we can use to create even the MEP elements in this case, and then we create the roof, and also we put the layout planning inside. So this is just a short graphical representation how it could be done. So how do we integrate that building now into the different workflows, also into the production processes and so on? So there are different ways of doing it. So the integration of a building data is becoming increasingly important. So it allows collisions to be detected in advance before they generate high cost on the construction site. Building data can be integrated in Inventor with Inventor AnyCut, linking a Revit or IFC file, for example. And so in this case, we do see the production planning, and we have the technical building equipment from Revit. So we just import that. We can link it with AnyCut, link it to Inventor, so the technical building equipment and also the building, and then have that building integrated. Here you can see an example with construction spaces modeled in Revit and imported or linked in Inventor. Those spaces can now be used to not only insert production machines inside of available areas, but also to see limitations like available heights in a three-dimensional space out of the building. So working with a construction space can not only replace the classic DWG floor plan, it adds BIM workflows and advantages to it. In order to achieve the best possible coordination of the building, MEP objects and production layout, it is necessary to coordinate the common origin of the project. The easiest way is to use the Revit origin that can be read by Inventor and will be aligned for all further workflows. With this approach, collisions can be detected and eliminated at an early stage. In this case, you see just the spaces that we have, but of course it can be coordinated further more. So when we have the whole MEP elements, you can see the collision here again. So let's have a look at this video to see that live. So in Revit, these construction spaces have been defined for each project stakeholder for project coordination. In a separate view, only the build spaces are visible to simplify integration with Inventor. In Inventor, we can use any cut for Revit to load this view and place it at the origin. Now you can clearly see that the cabin of the machine collides with the installation space of the MEP model, what we could see in the slide before as well. And before talking about cloud collaboration, we don't want to forget about our coordination solution, Navisworks, that can perfectly integrate all of the above created objects and projects. So in Navisworks, you can easily do a walk around, a walkthrough, and it helps to speed up the bidding and planning processes. But of course, we have the collision detection, and you can see we just found the collision with the machine and with the MEP elements in here. Now let's have a look at the coordination and collaboration for digital factories within the cloud. In this case, we have a look at the production planning view first. So in the production planning, we want to integrate the technical building equipment and the building design. In that case, we just have an early integration of the building data into the production planning. So we just read or we just upload the Revit files into the Construction Cloud, and from the Construction Cloud, those files can be read by Inventor with any cut. And that is an easy way of using the Construction Cloud and sharing the same data in the Construction Cloud. On the other hand, we have a look at the building planning. So the building planning needs to integrate the production planning. So how can this be done? In this case, there's possibilities with Inventor or FDU for Inventor to export a Revit file from Inventor and then to publish that Revit file into the Construction Cloud. So in Revit, we can read that published Revit file out of Inventor and can use it in the Revit project itself to coordinate, for example, the MEP installations and so on. Here we have a look at a project out of Inventor uploaded as a Revit project into the cloud. And these projects can now linked into Revit and can be updated because it's just linked. And then, as you can see here as well, we also have the possibility to use those files for coordination processes. So like we've seen in Inventor, like we've seen in Navisworks, we have possibilities to do collision detection as well here in the cloud with all those different files. Now let's have a look at another way of exchanging data. We are not we don't want to exchange files, we want to exchange data only. And for that we have developed the Autodesk Data Exchange. With the Autodesk Data Exchange there's a possibility of exactly not sharing files, but sharing data, metadata only, so objects only, for example. So there are different connectors for a lot of different solutions, and not only Autodesk solutions. As you can see here, there's IFC, there's Grasshopper, there's Rhino, and a lot of different other solutions where connectors are available to exchange data. How does it look like? We've seen the way of using Inventor, exporting the Revit file, publishing the Revit file to the cloud before, and the new way is that we just go ahead and we just have used the granular data in this case and not the files. So we just use a different view inside of Inventor and send this to the data exchange, or use the data exchange to send this to the cloud. And we can do the same for Revit. And both views can be read in the different solutions then, without the need of thinking about a file that we need to export, like DWG, IFC, or whatever. We just exchange the data. And now let's have a look at how this could look like. So in a new factory, the general contractor defines the construction spaces for the required production lines and the media supply, like we've seen this before. For this purpose, an additional 3D view is created in Revit, in which only the construction spaces are displayed. Using the data exchange, this view is uploaded to the Construction Cloud. The data exchange can now be opened in the Construction Cloud directly from Revit. All properties and a search are available there. Now the layout planner of the production A can call this data exchange from ACC. Check it via the preview and insert it directly into Inventor. The data exchange is automatically inserted on the 0 point. Thus the correct location is always guaranteed. The data exchange takes over the model structure from Revit. This allows the layout planner to hide the construction spaces that are not required. The layout planner can now plan the required production line based on the installation space. After completing the production line, the layout planner also creates the data exchange from Inventor in order to hand over the production line to the general planner. The data exchange can also be opened directly from Inventor to ACC. And the data structure from Inventor is also available. In the last step, the general contractor exchanges the construction space for the detailed production line by inserting the data exchange from Inventor into Revit and hiding the construction spaces. Let's have a look at Autodesk Informed Design now. It is similar to Autodesk Data Exchange, but the difference is that here we don't want to be open to everybody. We want to really have a high quality data exchange between Inventor and Revit, but still with granular data and no files included. So how does it work? But first, imagine there's different products that you need in a building project. For example, a balcony that you can see here. It could be windows, it could be doors, it could be any MEP objects, for example, on a rooftop, whatever. There's a lot of different elements that need to be manufactured first, and that manufacturing is being modeled and developed in Inventor. After Inventor, you want to send over the model to the building designer, so to Revit. But it should be intelligent. You want to have all the parameters available to adjust it to the size that you need for your project. And after you have selected the different sizes that you need, You want to send the final selection and the final sizes, the final projects or products back to the factory so that fabrication details can be created and it can be manufactured. This is the workflow that we wanted to create with informed design. Let's have a look at informed design with an example. It's not the balcony, but it's a staircase. An escape staircase detailed in Inventor and used as a parametric family in Revit. So we start in Inventor. To simplify the data exchange with the architect, the emergency staircase contains different model states, allowing simplified models to be exchanged with improved performance. The designs offered are created in Inventor with the help of iLogic to prevent special solutions. With the BIM definition tool, the dataset can be enriched with all the necessary properties that can be read afterwards in Revit. So we start with the insert behavior in Revit. So in this case, we use floor-based. It means that the staircase can only be placed with the upper landing on a floor slab. And even the insertion point can be defined. The next step is that we have a look at the Revit category, and we define that. We define the Revit family name, the family type, and Omni classes. The family can then be defined beforehand with iLogic so that a unique description is available. Now we can start the publishing in Inventor, and we just search for the right project, and we define the output sources. We define the different parameters that we want to exchange, that we want to have access to, that we want to read afterwards in Inventor. And now they can be defined much more. There can be calculations and so on, but I will jump here a little bit further. So these are the outputs that we need afterwards. We want to have the AEC output, so we want to have PDFs, for example. We want to have SAT files. We want to have Excel sheets of the bill of material and so on. So that's what we all define now. And now we just go to the project in the Construction Cloud, and we just define where we want to save it to. So there's a stairs folder in the Construction Cloud itself, and we just save it to there. The next step is we go to Revit, and inside of Revit we start the informed design tool as well. And here we find exactly the stairs that we've just defined. And you can see all the parameters that we defined before in Inventor are available. So now I can select the stairs with the parameters I need for my project. As we've seen before, it's floor plan based, or floor based, and so we just define the insertion point and we just insert the stairs in here. What you can see here now is that we defined, or we had the wrong parameters. The stairs are a bit too high. So what we can do now, we just go back to informed design and we just exchange or change the height that we need. So it's just another product with another height, and we just could calculate that before, but we just say we want to just replace it by this one that was generated already, and now the height of the stair is perfectly fine. This is what we wanted. So it is the parameters that we can change, but not inside of Revit. You can see the parameters here in Revit as well, but those are readable only. So if we change the dimensions in here, nothing happens. If we want to change it, we just go back to the informed design product, change the parameters and insert it back. And here now you can see, after we have defined the right stairs, we just insert it, or we just save it back to the Construction Cloud. And from here we go to informed design again, and we generate the outputs. And the outputs we want to generate are Excel sheets, PDFs, so all the construction drawings that we need to have in here. So if I go here, all those construction documents are in the Construction Cloud now, and you can see these are the detailed bill of materials and all the different Excel sheets that we need, and the detailed fabrication sheets or views and PDFs as well. Let's have a look at simulations now. With FlexSim, you have the possibility to simulate the flow of any manufacturing process, material handling or people. to prove new layout designs and processes, to optimize existing production processes, and also to make accurate plans to solve production issues. Let's have a look at one example. In this example of a digital factory, you can analyze the data in real time to see where you have bottlenecks and productivity gaps. Because if you don't have the perfect balance of utilization for every machine, you're wasting resources and money. Through simulation, you can evaluate emissions for sustainability or measure energy consumption for profitability, allowing you to uncover problems before they occur. For example, if you want to avoid mounting a €4 million machine to the floor, only to move it later, along with everything else. There are different add-ins available for Autodesk Construction Cloud, for Revit and Inventor, so you can simulate processes and people of the building information model of your factory in the proper solution. Let's have a look at the infrastructure for digital factories now, because every digital factory needs to be placed in the right environment, and there's a lot of different other things for logistic planning and so on that need to be also taken into account. Let's have a look at an infrastructure example of a digital factory for the placement, the site evaluation and logistics planning with comprehensive analysis. InfraWorks allows us to quickly place a factory on the desired terrain. Here we are helped by the model builder of InfraWorks. There we enter the address and get the corresponding map view. By drawing a rectangle, we define the desired terrain section and give the project a name. A few minutes later, we receive an email notification that the model has been calculated. Now we can navigate to the desired terrain and create a flat intersection surface in the first step. As styles, we can choose different pavements or other elements. Using the data sources, we can now insert the building and place it interactively on the terrain. It can be a Revit file, but in this case it is a Navisworks file in FBX format, and then imported as data source. There's an associative link to the files, so they can be updated quickly. Afterwards, there are different possibilities for analysis, like sun analysis, for example, throughout the day, like wind analysis, and also water analysis, like flooding, for example, as we can see in a second. As you can see here, so we also defined green areas, we defined roads, we defined water areas, and now let's have a look at the flooding that we also can see to evaluate the terrain accordingly. A very important point can also be the traffic simulation around the site. It must be ensured that goods leave the factory just in time but also arrive. If this is not guaranteed at certain times, the logistics may have to be rethought. All these are possibilities to evaluate different sites in order to decide on the optimal location. A visualization is not just a nice rendering. It can present final digital factories and processes to decision makers, owners and other stakeholders. But there are also ways of visualization that help every designer in the planning phase to avoid overseen errors and reduce time and cost. Autodesk offers a number of ways to visualize data in projects, with cloud rendering from Revit or Navisworks, still images, but also panoramas, or even day and artificial light analysis can be rendered in the cloud with just a few clicks and in just a few seconds or minutes instead of hours. With 3ds Max or even VRAD, photorealistic, high-end visualizations and animations can be created, as we can see in these images and video. The cooperation with Epic Games allows all Revit users to also use Twinmotion for Revit without any extra cost. With a direct plugin in Revit, the data can be transferred associatively to Twinmotion. In Twinmotion, you can use a real-time rendering with high-end material textures and also the animation of machines, people, or cars. You even have the possibility to change the atmosphere, daytime, or even weather whenever you like, and snow will be covering your scenes. With Workshop XR, we have another way of visualization. In this visualization, we are not looking at a photorealistic rendering, we're looking at a visualization within the planning phase. And in the planning phase, we want to improve the design accuracy, we want to streamline the collaboration, we want to find issues much faster, also have a faster decision making. So let's jump into the product and have a look. So wherever you are in the world, you can just meet anybody, and you're looking not on a screen, you are inside the model. In this case, we're standing in front of the model, and we can have a look at that. We can zoom in, or we can scale it, and even hide specific layers or categories, and then we can jump into the project. After we have seen the whole project itself, then we jump into the project and examine it inside. There's different ways of examining it. For example, we can have a look at BIM properties or any properties of a file that you imported in here, because we have many different file formats that we can include, like Revit, like IFC, like DWG, like Navisworks, and so on. In this case, you can see we just measured the distance. If the distance is not okay, you can create a new issue. This issue is synchronized right away with the ACC, with docs. So it is the same way of creating issues. So if I have an issue inside of docs, I can jump into that issue in here and examine it in an immersive area. So it's not, like I said, it's not like looking at a screen, it's really jumping inside of a model. And customers say that it's much, much better. They find much more issues and they can take decisions much faster and easier, because they are really inside of that model and they can feel anything that they wouldn't see just in a 3D model. Last but not least, I want to talk about the operational phase. The effort for a 3D factory model is also worthwhile after commissioning as a digital twin. The existing data can be used for operational workflows in tandem. Assets can be enriched with additional properties and data. Sensors can be integrated for temperature, humidity, pressure, radiation, etc., which are displayed in the model via diagrams and heat maps. The data can be uploaded or even linked directly from ACC, accepting Revit files, IFC files, Navisworks files, and DWG projects. Let's have a look at an example of Autodesk Tandem. In this case, we have a look at the digital factory that we've seen before already. And if I jump here, so we have a look at the file formats that we can import or link directly from the ACC. And like I said, it is Revit files, IFC, DWG, or Navisworks files. The second part is that we can have a look at the history of all the data that we uploaded and of everything that happened throughout the different years. So it's the history of the whole model, but it can also be the history of single objects that we can see here. So the history of the columns, for example, when were the columns added. And maybe even if there's a change of property of any column, we will see the change here as well. The next part are the properties that we can see. So we have a look at one specific machine, and we look at especially at the installation status of that. So we have all the properties inside here. We can add other properties like asset properties that haven't been there in the design phase, and then we can filter them. So in this case, you can see there's the installation status that we have, and now we can filter that down. So we filter it by different installation statuses in here. So these are all the machines that were specified, these are the machines that have been ordered, and so on. We can colorize them so that we can right away see the different status right by color. And then we can have a look at the inventory list as well, so to really see that and to define that. So we can specify that, we can add more information, more asset information to that. When was the installation date, for example? What is the warranty date? And so on. Any asset information that we want to add here, we can always do whenever we want to do that. We go a little bit further to group that now. So we want to have just grouped everything by the installed date, for example, or installed status. So I can right away see which elements of machines have been just delivered, which haven't been installed, and so on. In another way, we just group it differently, so to the production phases, or production areas. So in this case, we exactly see in which production area are which machines, which are installed, which needs to be delivered, and so on. The next view, we have a look now. There are options for checking the ventilation system. In the event of a leak, you can check up to which node the leak has an effect. And last but not least, we look at sensors. We look at the sensors that we add to and that we can visualize in the digital factory. So the sensors, like I said before, can be temperature, humidity, pressure, radiation, whatever it is. Any sensor can be added and can be displayed in the model via diagrams and heat maps on the system or in the room. The sensors can be connected via webhooks to an HTTP endpoint specified by Tandem, with a history of saved data of 3 years to take proper decision on historic experiences. Now let's have a look at the conclusion of the whole presentation. As you can see here, McKinsey did a research and they said that the factory development outcomes remain consistently poor. 60% are over schedule, 70% over budget, and there's a $1.3 billion cost overrun, and that is an analysis from 500 factory projects globally from 2020 to 2022. This has to change, and we definitely need to change that by reducing money and by reducing rework, by reducing delays and so on. So the opportunity is to coordinate layout decisions across disciplines, to identify and resolve planning conflicts early, and to streamline handovers and approvals. And this can be done by aligning all stakeholders on a shared and real-time data model. Why does it matter? Talked about that. We want to improve you from fragmented processes, working in fragmented processes, to cross-functional collaboration. You can reduce delays and you can avoid rework and a lot of cost. It's your opportunity and responsibility to implement the digital transformation, to master the multiple challenges that we are facing these days, to stay relevant in the local or global markets, and to stay attractive for new talents, and to save the future of your company.